This problem asks, is f of x equals the absolute value of x 1 to 1? So to answer this question, you need a good definition of what 1 to 1 means for functions. This is the one that I use. Well, think to yourself, what is the definition that you remember if you've studied this before moving on? First, I'll draw a picture. I'll say if this is the domain, these are all the possible values of the functions. And this is the range. And if this is some value, we'll call it a, then when you plug a into the function, you get some other, well, not other, could be the same exact value, but you get some output f of a. What if for every single different value b, you get so far every different value is getting a different output. But if you have some value c that goes to the same value, is this still 1 to 1? In this case, not. So we could say if f of x equals f of y, then x equals y. If f of x equals f of y implies that x equals y, then f is 1 to 1. Let's use this as a definition. Now, if we use a definition like that, and if we find two values, say x and y, where f of x equals f of y, but x does not equal y, then f is not 1 to 1. So if we think that this function probably is 1 to 1, we might go off trying to find a way to prove that if the absolute value of x equals the absolute value of y, then x equals y. But if we find any two values that absolute values are equal to each other, but the values inside are not, what about this? Is this true? They're both equal to 5. So that means that the absolute value is not 1 to 1, because the absolute value of 5 is 5. The absolute value of negative 5 is also 5. but 5 is not equal to -5, so you found a counterexample. So the answer to this question is no. This problem says sketch f of x equals 4x minus 3 and determine the domain and range. So if you look at this function, what type of function is this? It looks a lot like a mx plus b, which is a linear function. So it's going to be a function whose graph looks like a straight line. So with the line, we can just find 2 points and then complete the line. So you can choose any 2 points. One point we could choose is, say x is -1. Then we're going to look at this point, and if we plug in -1, 4 times -1 is -4. -4 minus 3 would be -7. See if I've got enough here. 1, 2, 3, 4, 5, 6, 7. So about right there. So what if x is equal to 1? 4 times 1 is 4. 4 minus 3 is 1. So we got 1 to 1. 1, 1. Here I've sketched the line with a couple of particular points. What you could do is figure out where does it cross the x-axis? Where is the x-intercept? Where does this function equal 0? It's pretty easy to do. But the other question is, what is the set of possible values that x can take? Is there any value of x for which this function is undefined? Any value on the whole? I don't see one. So you could say that the domain is all the way from -infinity to infinity. And is there any value on the y-axis that 4x minus 3 won't take? No matter how high you go, you can find a value of x that will, or no matter how far down you go. So the domain, the range is also -infinity to infinity. This is a two-part problem. Part 1 says, define a function f whose graph is the upper half of a circle with center at the origin and radius 1. And part 2 is define the function g whose graph is the lower half of a circle with center at the origin and radius 1. So first, before we have the functions, let's draw the pictures of the graphs that they're talking about so we can see them. Here's a picture of what part 1 was talking about. So we have the top half of a circle. And so what are your thoughts? Think about what function you could devise that. Well, what is the equation? Not necessarily a function, but what is the equation for a graph of a circle centered at some point hk, and all of the points on the circle are a distance r from the center? If you've watched a video or have studied the equation of a circle, and if you've studied the distance equation, you know, let's say this point right here is x comma y for some pair of numbers x and y. So the circle is the graph of the equation for all the points that are equidistant from this center HK. And what it comes out to be is, for any xy, x minus the h squared plus the y minus k squared equals the radius squared. And so all ordered pairs xy that satisfy this are a circle with center at hk and radius r squared. And I said that this is an equation, but we want to talk about a function. Do you know what's the difference between those two? Think about that for a minute. So an equation is like a balance, where you're saying two things are equal. That's applicable to the circle, because x minus h squared plus y minus k squared for a given xy is equal to the radius squared, because that xy is the distance r from the center at hk. So we're saying with an equation what two things are equal to. But with a function, it's more like a machine where you're plugging something in and getting something else out. So this is the 4x minus 3 machine, and we push in at the input a -1, we will get out at the output a -7. So that distinguishes what equations are versus what functions are. Now, why is this important for this problem? Why can't we have a function that defines a whole circle? Think about that for a minute. So with an equation, it's possible that two x values have two different y values, or the same x value has a different y value that is also in the equation. What I mean is, here's a circle. Let's say that this is a circle of radius 1 centered around the origin. Now this right here, this is the x 0 and this is the y -1. This is this point on the circle. And the radius, the distance from the center, is 1. Well, this point's distance from the center is also 1, so it is in the equation. You got 0 and 1. So with an equation, it's possible for a single x value to have two different y values that satisfy the equation. But remember, a function is not a balance, it's a machine. And with a machine, a mathematical type of machine, it just, when you plug in one value, you're supposed to get one value out. If you have a mathematical function here and you put in a 0, and you have a function that can get you out a 1 and a -1 at the same time, then it's just not according to our definition of a function. So functions have more of a constriction that a single input has to have a single output, whereas equations, the first number in the ordered pair can have other values of the second number in the ordered pair that are satisfy the equation. So that's another difference between functions and equations. So now you can start to see why this problem has separated the problem into an upper half of a circle and a lower half of the circle. So let's start with the upper half of the circle. First, let's draw an equation. Now this point right here is 0, 0. This is the HK, the center of the circle. And this is some point x, y, which is on the upper half of the circle, we make sure to say. And this distance, this radius, is 1. Now, just writing this as an equation at first, we can say that x minus 0 squared plus y minus 0 squared equals 1, right? We can even make it more simple, since in this case the center is at 0. We can just rewrite this as and 1 squared is 1, so I'm just writing 1. Okay? This right here is an equation because it's true for a whole circle. But we want a function, y equals something, and we will call this the function. So let's first rearrange this to get the y all by itself. And in this case, the y squared. We're going to move this over here, right? So we can say y squared equals, we subtract x squared from both sides. We got 1 minus x squared. But how do we get y by itself? Yeah, we just take the square root of both sides. And now the square root of y squared is technically the absolute value, because what if y was 1? And the square root of 1 squared is 1. What if y was negative 1? Then negative 1 squared is 1. The square root of 1 is 1. So typically you'll find in most math textbooks, when they write down the square root of some value a, they mean the positive root. So given that, we can say that y is the square root of 1 minus x squared. And this means that y is positive, and y is positive in the upper half. So this is the equation for all positive values of y that are the distance of 1 from the origin 0, 0. So this is the answer to part A. By this point, part G is pretty easy, because now that we have a function for the upper half of a circle, we can see that since circles are symmetrical, if we want to find the lower half, the negative values of y that are on this circle, we just do this, because g of x is equal to the negative of f of x, right? So g of x is just the negative root of 1 minus x squared. And so this is why we had to break it up into 2 halves, because functions are like machines, not like balances. This problem says, is f of x equals the square root of x squared plus 1 even, odd, or neither? So for this problem, you need to remember what the definition of an even function is, what the definition of an odd function is. And these are found in math textbooks, precalculus textbooks, algebra books. I'll give you an example and see if you can catch on to what the meaning of an even function is Here's an example of an even function. This is x squared. If I told you that's an even function, here's another one. This doesn't even, I don't even have to define exactly how I made this function, but if I told you, okay, that's an even function. If I did one more, because you know they're even, they look the same. Well, just imagine that they're like reflections of each other. Okay, so you might say to yourself, okay, if they're reflections across over the y-axis, then they're even. Can you think of a more formal, rigorous mathematical way to say? Let's go back to x squared. Here's a point. Let's say this is, let's say this point right here is 2, 4. And then this point is minus 2, 4. Have you got a definition in mind for an even function yet? Let's say this is some value a. I didn't even say what it was. But this is a squared. And then the same distance in the negative direction, we have minus a. And we had minus a squared. Do you have a way of saying if a function is even? Okay, here's how I would say it, and not only me, this is where I got it from a book. You can say if f of a is the same as f of minus a for all a in the domain of the function f, then f is an even function. You'll find that if you apply this definition to all the types of functions that I drew, this applies, because every time you go the same distance in the opposite direction, the function has the same value. It doesn't even have to be all positive, like the examples that I drew. How about this function? You know, we're saying that, let's say this point right here was C. We're saying that f of b equals C. F of minus b also equals C. If this was true for every possible value, then this function is an even function. Is this the case for this function? Let's replace x with minus x. So we have this. Is it the case that minus x squared plus 1, take the square root, is equal to think about that for a minute. If I take the square of a negative number, am I always going to get yes, right? Because let's say x equals minus 2. Okay, when you plug minus 2 into this function, you're going to get minus 2 squared, which is 4. 4 plus 1 is 5. So this is the square root of 5. Now here, what is the negative of minus 2? Minus 2 is 2. What's 2 squared? 4. 4 plus 1, 5. Square root of 5. And you can do that with any number. So this function is definitely even. While we're here, we can talk about what odd functions are. What is an odd function? Let's draw some examples and see if we can find a pattern among these. If a function looked like this and I said, okay, that's an odd function. Or if I drew a function like this, and I told you, okay, that's an odd function. I'll just give one more example here. What if a function looked like hopefully I drew that right. If I told you that that was an odd function, now how do we define that formally or analytically using algebraic terms instead of pictures or words? Does it look like it's reflected around as if you rotated it somewhat? So if I said f of a is equal to, let's say I drew this function. This function is just defined on the closed interval from 0 to 1. And f of x equals x if x is on 0 and 1, and it's equal to minus x if it's on this interval. What is, and I said this is an odd function. What is true about here? Let's say this is a. And by this function, this would be a, right? And if this was minus a, this would be minus a. Then you would say that this is true for all values of the domain. Actually, there. Can you see what it is? this is a minus a. This is f of minus a is equal to minus f of a. Here's an example. Of an odd function. If I said f of x equals x cubed, let's plug in 3. F of 3 would be 3 cubed is 27. Negative 3 cubed, negative 3 squared is 9. 9 times negative 3 is negative 27. So yeah, if f of minus x is equal to minus f of x, then f is an odd function. All right, let's apply that to this to see if this function is odd. Is it true that all right, let's say that x were some positive value, then minus x would be a negative value. You square that, it's a positive value. You add 1, it's still a positive value. You take the square root, it's still a positive value. So now, if you think it is, try to give an example of where you plug in the negative of a value and you get a negative overall value. So yeah, this function is not odd, primarily because this function is positive for all values of input, right? So in this case, this is an even function. This problem says sketch f of x equals negative 4 plus x squared. And then what are the domain and range of f? So the first thing to do is look at this function right here and think what function is it similar to that you know. Let's start to draw coordinate axes. So if you know what is the function, what does this function look like? If you've seen the parabola function x squared, you know it looks like this. Now, we're building up functions out of functions. If we say, what does this function look like? What if you took every value from this function and you increased it by 4? What would that be? Well, if you take every point here and you raise it by 4, it's like a vertical shift up. Okay? And now with the minus in front, What do we know about making a minus in front of every one of these values? What's the, if this was A, then what is minus A right here? If this was 4, because if x is 0, then this is 4, and this would be at minus 4. Yeah, it would shift it minus, it would be a vertical, a mirror image over the x-axis. So if this was -4, so this is the sketch of what it looks like. What is the domain of this value? What x values can this function take? Another question, are there any values from -infinity to infinity that this function cannot take? No. So the domain is -infinity to infinity. Now the range, the values that the function can take as an output, that's a different story. Are there any values above -4? At 0, it is 4, right? So 4, -4, at 0, its value is -4. We should put it this way because there's no value above -4 that it is. Is there any value that it's not less than? No. So it goes all the way down. It takes on values all the way to negative as far as you can go. So the domain is from -infinity to infinity, and the range is from -infinity all the way up to and including -4. This problem says sketch f of x is 1 over x minus 4 squared. And what are the domain and range of f now? So I would start from the inside and sketch a function that I know. Let's say something vaguely similar to this might be the function x squared. And that one looks like a parabola. And as I'm looking at the parabola, I would say, I know that in my target function, this squared part is in the denominator. So while I'm looking, my strategy is looking at this function. If you took the reciprocal, if you took 1 divided by x squared, first of all, if x is 0, is this defined? No, division by 0 is undefined. So you know that right on x equals 0, the function is not going to be defined. But starting very near to 0, x squared has a very small value. If you take the reciprocal of a very small value, you're going to have a very large value. And as you get to the very large values, if you take 1 over that value, it's going to be very small. So if you take 1 divided by x squared, and you're looking at this function right here, you know it's going to look something like this, right? It's actually going to get very close to 0 very quickly. It's just going to get closer and closer to 0 as these values get larger and larger on x squared. But this is not quite the function that we want. what we want is 1 over x squared minus 4. So think of it this way. You start with this function, 1 over x squared. Now what value of x, what value of this function would make x, would make the denominator 0? It would be when x is 4 that it would be, right? So let's say x is 4. But we know when this function is 0, it's undefined. It's kind of like what they call a vertical asymptote, where the function is not defined. So when you have minus some amount, it's like this function is getting shifted to the right by that amount. So we take this function and we shift it to the right. So the function at this point right here, when is what is it when x is equal to 0? Let's plug x equals 0 right here. 0 minus 4 is negative 4. What's negative 4 squared? 16, right? And 1 over 16 is 1/16. It's a very small number. It's just good to know certain points, and it's going to get smaller and smaller. So here it is. This is what the sketch of the function looks like. You know, these sides are supposed to look the same. Question is, what is the domain? Can this function take any value between negative infinity and infinity? Or is there one certain value that it cannot take? What value can it not take? If x is 4, right, then this function is undefined. So we say it's defined from negative infinity to the open boundary, negative 4. We put the curved line, meaning that it cannot be at 4. And then union, this is the union symbol, can also be with an open boundary at 4 on to negative infinity. You could also say the domain is the set of real numbers except 4, right? This is interval notation. What is the range? This is not the real set of real numbers. This means range. What are the possible values that this function can take? Can this function ever make it to 0? Is this function ever equal to 0? No, right? It can get as close as you want, but it will never be at 0. Can it ever have a negative value? Can this squared quantity ever be negative? 1 is positive. No, right? So this function is always going to be greater than 0. So I put, now is there any value so large that this function cannot be equal to it? You can get as close to 4 as you want, and this is an extremely large value, right? So it can go up to infinity, towards infinity. So there's the sketch of this with these key values. At 4, there's a vertical asymptote. It crosses the y-axis at 1/16. And the domain is basically all values except for, oh, did you see that mistake that I made? You wouldn't want to have a negative right there. It's always good to double check your answers. And the range, the set of all positive values. I think that's it. This function says, well, this problem says, sketch f of x. And f of x is this function. It's 1 if x is an integer, and it's 0 if x is not an integer. So sketch that function. And then what are the domain and range of f? So let's just draw some coordinate plane. Let's put some values here. 0, 1, 2, 3, -1, -2, -3, and so on. And here is 1. So for these integer values, f of x is equal to 1. So you can use a different color for the function. So at 0, 0 is an integer. So the function's value is 1. At 1 is an integer. X is an integer. So the function is 1. And so on. And all these other values, let me make it a little bit higher. All these other places on x, which are not integers, the function is going to be on 0. I'm just going to draw it close. And you see at 1, it's not on 0, so I'm going to draw like a open circle. Okay, there's a sketch. What is the domain of this function? Is there any value of x that is not defined? Is there anything here? Not really, because x is either an integer or not an integer. And we just say every value on the x-axis is either an integer or not an integer? Yeah. So every value on the x-axis is defined. So the domain is from -infinity all the way to +infinity. But the range for this function, look at this. What values can this function take? Is there even an interval of values? There's actually exactly 2 discrete values that the function can take. 0 and 1, right? So this notation, see these curly braces? First of all, what does this mean in interval notation? It means 0.5, 0.225, there's an infinite number of real numbers between 0 and 1, not including 0 and 1. But this function cannot take a whole interval of values. There's 2 values. So in this case, the range is discrete, means it can take a finite number of values, in this case just 2. It means the output of this function is either 0 or 1. So we've sketched it. It looks like this. And the domain is the set of all real numbers. And the range is specifically the set including 0 and 1. This problem says, find the domain of f of x equals the square root of 7 minus 2x. So with domains, you need to find out the set of values for which this function is defined, which values are valid input values. The biggest thing is this is the square root, and we know that for real numbers, the thing inside here cannot be negative, must be 0 or greater, right? So, solution path, we can set up an inequality. What inequality would you set up? 7 minus 2x is what? Is this the right inequality to search for? Is this value allowed to be exactly 0? Yeah, because the square root of 0 is 0, because 0 squared equals 0. So we'll do this. This means we want to know all values of x for which 7 minus 2x is greater than or equal to 0. Okay, what would you do the first thing to get x by itself? I would move this minus 2x, I would move it over by adding 2x to both sides. So you got 7 is greater than or equal to 2x. To get the x by itself, divide both sides by what? 2, right? Seven halves. So this means that x always has to be greater than or equal to 7 halves. Or less than or equal to. I'm sorry, I've been saying the wrong words. X has to be less than or equal to 7 halves. So on a real number line, we've got 0, and somewhere along the way we've got 7 halves. And this square brackets means it can be at 7 halves. Or in other words, we could write the interval from negative infinity all the way to and including 7 halves. So the domain is from negative infinity to the closed boundary of 7 halves. This problem says sketch and determine the domain and range of f of x, and f of x is equal to this function, and this is the value that it is for the interval stated after the comma. I encourage you to pause the video and look carefully at the inequality symbols right here to determine exactly which piece of this piecewise function applies for every single point on the x number line. Because when you're sketching the function, which one of these applies depends, especially at these boundary points. You want to pay close attention to these less than and less than or equal to's and greater thans. So after you look at this for a minute, we'll continue. So here's the function definition written up top. And here's a bit of a XY plane drawn right here. Let's start with the values of x less than -5. We're talking about 1, 2, 3, 4, 5. All values here. I'm just drawing the arrow right now so I can see which values. And for values of x less than that, the value of the function is a constant, which is -5. 1, 2, 3, 4, 5. All right. But notice the less than sign, so it does not include, this one does not include -5, but for all values, -6, -7, and so on. See if I can. So that's that part. And now at -5 and until, I think I wrote it down wrong. I think I should have had that. From -5 to +5, the function takes the value of x, which is a linear function. So at 5, 1, 2, 3, 4, 5, the function has the value 1, 2, 5. Right? At 0, it has the value 0. At -5, it fills that hole because it is the same value, -5. So every continuous value in between, it's like this. Okay? And now, for all values greater than 5, the function has the constant value 5. So that's what the function, the sketch of the function looks like. The domain. Is there any value of x for which this function does not have a value or is not defined at? Or does it have a value for every possible x value? Yeah, it has a value for every possible value. Because this one and this one, they meet up at the same boundary point. And this one has the same value as this one at 5. There's a topic in calculus which you can learn of later called continuity, continuous functions, where this will come in. But for now, the domain of the function is from -infinity to infinity. Now the range. What values does this function take? What are all the possible values that this function can take? Look at the graph. Is there any value less than -5? Can the function take? Can the function take the value -5? Yes, we see that it includes the value -5. How about in the positive direction? What's the highest value that the function takes? Clearly, it's 5. And I started already to put the interval because there's no value between -5 and 5 that the function does not take, right? So the range is the closed boundary from -5 to 5. So there's the sketch, the domain, and the range.